In the last session, we looked at the substring search problem and we looked at how to solve that problem using the brute force approach. So again, a quick recap about the substring search problem is we are given with a string P and we like to find if a pattern Q exists in that P. So the brute force approach that we had solved in the last session was clearly a quadratic running time in the worst case, especially if the size of the pattern is nearly equal to n, then it would be roughly quadratic. Um, but then there is a solution proposed by Rabin and Karp, also known as the Rabin-Karp algorithm, which uses a hash to perform the comparison. And clearly, that this Rabin-Karp algorithm has a potential to be a linear running time when it comes to the substring search problem. So the idea is we calculate the hash of the pattern and the substring, and we extract substring by substring from window to window, and then we check if the hash of that pattern matches the hash of substring, then we do the compare, else we increment to the new window. So we will look at first how to generate an initial hash, and we will also look at what's known as a rolling hash. So given a string with a bunch of characters, let's say A, B, and C, the initial hash is simply taking the number representation of that character. So here we are using the alphabetic order. So A here has a number 1, B 2, and C has 3. And then we multiply that with the power of that alpha there, where alpha is simply the prime number. It can be any prime number. Here we assume it's 3. So it's going to be 1 times 3 to the power 0 plus 2 times 3 to the power 1 all the way, and we get 34, right? So that's for the hash generated for ABC. Um, what if we have multiple characters and we want to generate a hash called the rolling hash based on the previous window? So here we use the formula in this algorithm to calculate the rolling hash, and this is done in constant time because we get the hash of the previous window and we subtract that from the start of the previous one. So in this case A, and then we divide that by alpha, which is the prime number, and we add it to end of that new window, times alpha to the power of length of that window minus 1. And length of the window here is 3, right? So we assume it's 3. And then you can see that we are doing 16 minus A divided by 3 plus B times 3 to the power 2. 16 here is simply the hash of the previous window, which is ABA, right? So hash of ABA, we already computed that and we got 16. And this is why you could find that the hash of previous one is 16 here. And if we solve this mathematically, we will get the new hash for the second window, which is M2, to be 23. And the same thing could be done for M3, right? So again, we can find that the R hash of M3 is simply going to be 25, right? So we have 25 there for the R hash of M3. And the Rabin-Karp example is again similar to the brute force, except that we are not going to do item by item comparison. Here we simply check if ABA, if the hash of that matches with Q, right, with the given pattern. And here it's a miss. Second time you go and run it again, BAB and ABB, and you get a miss again. Third time, there is a match between the hash of the substring ABB and the hash of the pattern here, ABB. So you go and compare at that time item by item, and then you get your final result, right? And again, regarding the time complexity, as we said, the rolling hash takes a constant time, and then all we are doing is we are comparing it only when we know that the rolling hash matches, right? So in terms of time complexity, it would be p times m, and then here, if m is a very small number, the worst case clearly would be linear, right? So it all depends on the hashing function as well. Okay, so a good hashing function would result in a good time complexity here in this algorithm, and which would clearly take a linear time. And the reading assignment for today would be chapter 5, 5.3 in our textbook. And if there are any questions, feel free to ask. With this, we will wrap up the discussion on string algorithms. So thank you for listening, and I also like to thank you guys for this great semester. It was a pleasure working with you all. Okay, if you have any questions, feel free to let me know, and we can discuss about that. I would also write up a note in Slack related to my final virtual office hours and other administrative stuff. Okay. All right. I'll end this video here. Thank you.